For our last section in Chapter 2, now we're going to talk about solving inequalities. Inequalities. So that's not just an equal sign, but it could be greater than. Our inequalities are greater than or equal to, less than or equal to. So x is not going to have a single value. X can have any value that might be greater than a number or less than a number or greater than or equal to a number. So that's what we mean by inequalities. And in order to know how to write your answer, you will need to understand a number line, and once you've put your answer on a number line, you're going to convert that into interval notation. Interval notation. Interval notation is a shorthand notation for what are allowable values for x. And it always starts with the smallest value, and then it ends with the largest value, separated by a comma. There may be parens, or there may be square brackets. Your smallest value and your largest value. So, in other words, x can have any value greater than the smallest and less than the largest. Now, if x can equal the value, you see how the equal sign is made of two straight bars? Think of this as, okay, and it can also equal. X can be greater than or equal to the smallest value. X can be less than or equal to the biggest value. So, you need to remember that parens, there is no equal sign. It's greater than or less than. The brackets, there will be an equal sign, meaning greater than or equal to or less than or equal to, and the smallest number is always first. And this is a reminder, for infinity or negative infinity, you will never be able to equal infinity or equal negative infinity. It's impossible. So if you ever have infinity or negative infinity, it's always going to be a paren. So we're going from smallest to largest, and depending on if there's an equal sign, we might have a square or a paren bracket. The smallest separated by the largest by a comma. So you'll be able to identify linear equalities and graph the solution on a number line. Once you have the number line, then you can go to interval notation, and then we'll solve some inequalities. And compound inequalities are where you have more than one condition true at the same time. And then we'll end with a word problem. All right, so classroom example 1. Graph x is greater than -3. So x can have any value. On our number line, I always like to put 0 so I kind of know where the negatives and the positives separate. 1, 2, 3. Here's my -3 on my number line. Do I have an equal sign here? No. So any number greater than -3, x can be -2, x can be -1, x can be 5, x can be way down here at 100. X can have any value greater than -3. So I'm going to put a paren because there was no equal sign. And all of these values on the number line are allowable values for x. That is the graph of x greater than -3. That's the graph. Once you have the graph, you use the notation on the graph to go right into interval notation. As I'm going along, what's the smallest possible value for x? It's -3. Can x equal -3? No, I don't have the little bar there, so that's going to have a paren. So the smallest value for x would be, it's got to be greater than -3. And then look, it goes off into infinity. X can have any big number. And can we ever equal infinity? No. So x greater than -3, this is called inequality notation. This is called graph notation. And this is called interval notation. All three of these are saying the exact same thing, but they're using different notations. Inequality notation, graph, interval notation. In this case, they asked us to graph it, and they asked us to give the answer in interval notation. So why don't you go ahead and try practice? Oh, no, you know what? We're going to move on to classroom example 2 before you do a practice. So solve and graph x minus 6 is greater than or equal to -11, and then write interval notation. All right, so they want all three notations. X minus 6 is greater than or equal to -11. Well, just like when we solve equations, we want to get x by itself on one side of the inequality sign. So I'm going to add 6 to both sides. So now x is greater than or equal to -5. That is the solution in inequality notation. Now let's graph it. Here's my 0, 1, 2, 3, 4. Here's -5. X can have any value greater than, and it can also equal -5. So since it can equal -5, we're going to put the bar. And x can be -4, -3, x can be 0, x is going to can go up into an infinity. So this is the graph. And then once we have the graph, we're going to use interval notation. So what is the smallest possible number for x? -5. Can it equal -5? Yes, it can, because of that little bar. So that's how we would say x can be greater than or equal to -5. And we can go up to infinity. And since you never touch infinity, you'll always have a paren. So this is interval notation for your answer. Now you're going to go ahead and try practice 2. Looking at classroom example 3, again, they're going to ask us to solve, graph, and write in interval notation. So I have -3x is less than or equal to 12. So here's a very important math fact. When you multiply or divide by a negative number, you must swap the sign. Swap the inequality. So if I want to get x by itself, I need to divide by -3. But if I divide one side by -3, I have to divide the other side by -3. I'm left with x. But because that was negative, my less than or equal is going to become greater than or equal. You swap the sign. If there was a little equal sign, you also include the equal sign. If this was just less than, this would become just greater than. And then a positive divided by a negative is a negative. So x can have any value greater than or equal to -4. So we're going to draw our number line, 1, 2, 3, here's -4. Can x equal -4? Yes, it can. But x can have any value greater than -4. So that would be the graph. And how would we convert the graph to interval notation as we go along? The smallest possible value for x is -4, and since there's an equal sign, we're going to use the square bracket, but infinity can never be touched. So this is the kind of thing you would definitely want to check. How would I check this? All right. Pick a number that you think is in the solution region. Pick 0. If this is correct, 0 should be in the solution. So -3 times 0. You go back to the original inequality and see if it's true. I'm picking a test point in the solution region that I think is true. So anything times 0 is 0. Is 0 less than 12? Yes, it is, which means I do have the correct solution region. All right, so remembering to swap when you multiply or divide by a negative is very important. Let's try classroom example 4. Here we're told that -3x plus 11 is less than or equal to -13. All right, so we want to get the x by itself, so I'm going to subtract 11 from both sides, and I get -3x is less than or equal to -24. So again, I'm going to divide by a -3. When you divide, you swap the sign. And a negative divided by a negative was positive. So x can have any value greater than or equal to 8. So if I draw my number line, if this was 0, 1, 2, 3, 4, 5, 6, 7, here's 8. Can x equal 8? Yes. And can go on and on. That would be my graph. So my interval notation would be 8 with the square bracket, but off to infinity. And let's check our answer. If this is correct, I would think I'm going to pick the value 10. I'm going to check and make sure 10 is in the solution region. Why do you want to do this? Because if you've forgotten to swap your sign, your arrow is going to be in the wrong direction. This is how you're going to catch your wrong answer. So go back to the original, but plug in some number greater than 8 and see that you still get a valid answer. -30 plus 11. Is that less than or equal to -13? -30 plus 11 is -19. Is that less than or equal to -13? Yes, it is. So now you're going to try practice 5.